Hey guys, morning everybody. Just let me know if you guys can hear me before I start this. Right? Like I said, just let me know if you guys can hear me before I actually start this, okay? Okay, great. All right. So guys, I have a little time this morning here. All right. So I'm just gonna be doing a free session this morning. More than likely I'll be live tonight as well. But I hope you guys are doing well in terms of preparing for the exam tomorrow. What I'm going to be doing today, I'm going to be doing a range of different kinds of questions that could appear in the exam. So let's have a look at this question here. And this is typically question 7 in your exam. All right, this is typically question 7. I have multiple screens open here, so I hope you guys are seeing properly. Okay, so a sequence of figures is made up of stars using dots and sticks of different lengths. The first 3 figures in the sequence are shown below. Now, question 7 is a question, if you know what you're doing, you can gain some marks very easily. In some questions, you have to draw what the 4th figure is in some of these questions. But this one here, we have a sequence here, and we notice that the stars are getting larger and larger. What we need to do, we need to study the pattern in this table here, and then we need to complete the table. Now, this is typically a 6-mark or a 7-mark question. So we have each of the figures here. You have figure 1, you have figure 2, and you have figure 3 here. And if we look at the table, we have number of sticks being used to make the figure, and we have number of dots being used to make the figure. So in this case here, what we're going to do, we're going to look to try to figure out what the pattern actually is here. Now, the first thing I would suggest to you is to look at the numbers to see what's happening. When I jump from here to here, I have increased by 12. So if you go from 12 to 24, you are increasing by 12. When I go from 24 to 36, you are also increasing by 12. And the same thing here, when we go from 36 to 48, we're also increasing by 12. Now, if you do get a pattern like this in the exam and there's a constant increase, this pattern is easy to figure out. That 12 that you see being repeated all the time is going to be in your formula. So what I normally tell students to do is to figure out your nth term first of all. Let's figure out the formula for the number of sticks if we have figure n. So since we have 12 being repeated all the time, what that suggests is that in our formula, we must have a 12n in the formula. What we need to do now, we need to do a test. If we were to take figure 1, whatever I do, I need to be able to get 12 as the number of sticks here. So if I have 12n and I plug 1 into that formula, 12 by 1 will give me 12. So that formula holds true. If I were to test it with 2, 12 by 2, we get 24. So it also holds true. So that statement there is correct. It is going to be 12n. That's the formula for the number of sticks in figure n. If we were to look at the second column here, the number of dots, let's see what's happening here. As I jump from 13 to 25, I've technically added 12. If I jump from 25 to 37, I've also added 12. And if I go from 37 to 49, I've also added 12. So as you can see, 12 appears to be repeated again. Now in these kinds of questions, that's a very easy question when we see a common repeat. So in this case here, I expect to see 12n into the formula. But you need to do a check to see what else do I need to do. If I have figure 1 here, I should get 13 as my answer. So when I have figure 1, I should get 13. So if I'm using the formula 12n, it'll be 12n plus 1. So if I plug figure 1 into that formula, it is going to be 12 by 1, which is 12 plus 1, and we get 13. If we test it with the second figure, 12 by 2 is 24. 24 plus 1, we get 25. That's also correct. So the first thing I would suggest that you do in a question like this is to try to figure out, right? Is to try to figure out which one, right? Which one is actually going to give me the correct answer here. So 2 marks for this, right? 2 marks for this. Now, once you have that now, you can go and work out anything else in the table. So if you want to work out for figure 1 and you want the number of sticks. So the number of sticks here is given by 12n. Right, that's the formula for the number of sticks. So in this case here, if we have figure 5, it'll be 12 by 5. and this is going to give us 60 here. So in this case here, this number is going to be 60. So that's for figure 5. For the number of dots here, the formula, so the dots formula is equal to 12n plus 1. So this is going to be 12 by 5. That's 60 plus 1. So that's going to be 61. So this number here is going to be 61. That's it. All right. So we worked out that row there. Then we need to work out this second row here. So we have the number of sticks being equal to 56. So all you need to do is to say the number of sticks is 12n, and that is equal to 156. So therefore, n is equal to 156 over 12. So therefore, n is equal to, so 156 divided by 12, we're going to get 13. So this corresponds here to figure 13. In our 13 figure, we're going to have 156 sticks. For the number of dots now, all I need to do is the same formula. So the number of dots is equal to 12n plus 1. All right. So this is going to be 12 by 13, right, plus 1. But if you notice something here, the number of dots is just one more than the number of sticks. So without a calculator, I know this should give me 157. Okay, this is 157. So again, once we have questions where we have a repeated term, all right, those are easy patterns you can figure out. Okay, give me one sec. I have so many windows open here. Where'd I put you? All right, so this is part B of this question here. Yeah, somebody's asked about transformation. Yeah, I have some slides here on transformations to give you a hand. Okay, so maybe I might do that next, right? I might do that next. Okay, so what do we have here? We have the sum of the number of dots in 2 consecutive figures are recorded, and this information for the first 3 pairs are shown in this table here. So what they're saying here, we have the sum of the number of dots in 2 consecutive figures. Now, when we speak about consecutive in maths, we talk about one after the next. So 2 consecutive figures could be figure 1 and figure 2. Then we could also have figure 2 and figure 3. And then we could have figure 3 and figure 4. Okay. So we have the total number of dots in consecutive figures. We want to determine the total number of dots in figure 7 and figure 8. Okay, so remember, we do have a formula for the number of dots. It is 12n plus 1. So D is equal to 12n plus 1. That's how we work out the number of dots. So for figure 7, if I want to work out the number of dots is simply going to be 12 by 7 plus 1. So that's 12 7 is 84 plus 1. That's going to give you 85. And we need to figure out for figure 8. And the number of dots in figure 8 will simply be 12 by 8 plus 1. That's 12. It's a 96 plus 1. That's 97. But they want the total number of dots here. So we need to add these 2 numbers here. So that's 7 and 5 is 12. 9 and 1, 10. So that's 185. Okay. So they want the total number of dots in figure 7 and figure 8. And the last part of the question here, they said the total number of dots in figure n and figure n plus 1. I normally call these little fillers that CSEC put in here just to make up the marks, right? Because we are essentially using what we already know. So if you want to work out for figure n, so figure n, we do already know that the number of dots is 12n plus 1. We already could figure out what is figure n plus 1. That's the figure right after. So if you want to work out the number of dots, then all I need to do is to plug n plus 1 into this formula. So this is going to be 12n, right, plus 12 plus 1. So this is going to be 12n plus 13. Okay, so you want to add up all of the dots here. So we're going to say 12n plus 1 plus 12n plus 13. So when I add this up here, 12n plus 12n will give us 24n, and then 1 plus 13 will give us 14. Okay? Right? Let me see something. Some people say it's blurry. Anybody else see that blurry? I normally stream in HD, guys. All right. Right. I'll probably be going till maybe 1 o'clock, maybe. Okay, good. All right. Let's see what else I have here. Okay, so that's a question 7, right? That's a question 7 here. Let me look at a question 8 here for you guys. Now, question 8 is typically relations, functions, and graphs, right? Relations, functions, and graphs. So in this case here, let's try a question here. All right, we want to solve a pair of simultaneous equations. Some students don't realize that this actually falls in question 8 as well. So we have two equations here. We have y squared plus 2y is equal to 11, and that is equal to x. And we have x is equal to 5 minus 3y. So the first thing we're going to do, we're going to call this equation 1. So always label your equations. We're going to call this equation 2. And then all we're going to do, we are going to substitute one into the other. But if you notice something here, this is equal to x, and this is also equal to x here. So what we could do, we could just say substitute equation 1 into equation 2. Right, so substitute equation 1 into equation 2, and then what's going to happen here, we are going to say y squared plus 2y plus 11 is equal to 5 minus 3y. Okay, so now we have a quadratic here in terms of y. So we can say that y squared plus 2y plus 3y plus 11 minus 5 is equal to 0. So this is going to give us y squared. Now 2y plus 3y will give us 5y. So this is 5y. And then we have 11 minus 5. That's going to give us plus 6. So what we do have here, we have a quadratic in terms of y. So the first thing we need to do, we need to factorize this here. Okay, so we could probably say 2 and 3 here. So plus and plus. Yeah, that looking correct. 2 by 3 will give me positive 6. 2i. Yeah, this looks correct here. So that's step 1. We're going to figure out our y values. So we can say either y plus 2 is equal to 0. So y is equal to negative 2. Or we can say that y plus 3 is equal to 0. And therefore y is equal to negative 3. So we've just worked out our two y values here. The next thing we need to do, we need to figure out x. So we're just going to substitute x into any one of the equations, but my suggestion is this one. So this is going to be 5 minus 3 by y, which is minus 2. So this is going to be 5. Minus 3 by minus 2 will give me plus 6. So this is going to give us 11. So therefore, one solution here will be minus 2 and 11. And the next thing here is we're going to have x is equal to 5 minus 3 by minus 3. So this is going to be 5 plus 9. So that's going to give us 14. So therefore, the second solution is going to be, all right, sorry, I wrote this wrong. Right? I have this wrong side. My bad. Right? In this case here, we had worked out y first. So this is actually 11 minus 2. And this one here is going to be 14 minus 3. Okay? Right? So this is something that could appear in question 8 of your exam. Right? What else I have here? Oh. So I don't think we had one of these in a little while. So have a look at this one here. So sometimes in the exam, we may be asked to complete the square, and you guys can use whatever technique that you are familiar with. Okay, whatever technique that you've learned and you're comfortable with, you go ahead and use that to work out or complete the square. All right, I know some people, they've learned of a formula to work out this, and that's fine. That's fine, nothing wrong with that. Okay, so we have a function here, and this function here is a quadratic, and we want to write it in this format here: a open brackets x plus h squared plus k. Now, if ever you see you are being asked to write a quadratic in that format, they are actually telling you to complete the square. That's what they do. So I have a technique that I normally teach my class, so that's the technique I'm going to use here. So 4x squared minus 8x minus 2. And what we're going to do, we're going to complete the square. Now, the first thing I do when I'm completing the square is to factor out this 4. Now, some students, they get a little confused here when you're factoring out the 4. Let me just show you what I'm doing here. 4x squared minus 8x minus 2. What I'm going to do, I'm going to divide every single term here by 4. Okay? So when I do that, I'm going to get x squared minus 2x minus a half. So in this case here, when you factor out this 4 here, you're going to have a bracket. And this bracket in this case here will be x squared minus 2x minus a half. Okay, so let me double check that. 4x squared minus 8x minus 2. Okay, good. Right, so that's step 1. I've just factored out that 4 there. The next thing I'm going to do, I'm going to try to complete the square. So when you're completing the square, you're going to have a bracket that needs to be squared. First thing in the bracket is always x. And then what we're going to do, we're going to find half of this number here. Half of minus 2 will give us minus 1. The next thing that comes in this line here, you're going to write back the term from above, which is the minus a half. You're going to write a minus sign, always a minus sign, and you're going to put this number squared here, which is 1. So in this case here, we're going to get 4. So let's clean up inside the bracket first. So this is going to be x minus 1 squared. Minus a half minus 1 is minus 1.5, which is minus 3/2. And the final step in the process is to multiply the entire equation by 4. So this here will become 4 open brackets x minus 1 squared. And when you multiply this by 4 here, you're going to get minus 6. Okay? So this is our completed square here when it comes to this. Okay? Right? So guys, just remember to please remember to share. You can share this with your friends, no problem. All right? It's free for everyone to get some help just before the exam. So that's part 1 here, right? That's part 1. The second part, they said state the minimum value of f of x. Now, one of the key things when you complete the square is that you are able to actually determine the minimum value from the completed square. And it's usually whatever key is here. So this part 2 here, when they ask us for the min value, so the min value of f of x, in this case here is simply whatever k is. So k in this case here is minus 6. That's it. Okay. And the third part, they said determine the equation. So you want the equation of the axis of symmetry. Now, when they want the equation for the axis of symmetry here, what they're really asking us for is the x coordinate of the minimum value. All you need to do is when you complete the square, this bracket piece here, we need to put that equal to 0. So you're going to put x minus 1 is equal to 0, and therefore x is equal to 1. So that's your equation for your axis of symmetry. Now, sometimes you could be asked to sketch a curve, and if you are asked to sketch a curve, the fact that this number in front of the x squared is positive, this curve actually looks like this. It has a minimum value, right? It has a minimum value. This minimum point here is actually given by 1 minus 6. That's the minimum point on this curve here. The axis of symmetry, that's this line here, has an equation given by x is equal to 1. Okay? So that's a typical question that we could get in the exam. We haven't really gotten one in a little while, so just look out for it, right? Just look out, make sure you know what to do. This next part here, we have a speed time graph. So speed time graphs do appear, right? Do appear in the exam. So let's see what we have here. Right, so we want two things here. We have a speed time graph, and we want to work out what's the acceleration in these two stages here. Okay, so if you are given a question like this in the exam here, they want to work out the acceleration. So you want acceleration here. Now this here is a speed time graph. If you want to work out acceleration, all we need to do, we need to basically work out what is the slope of the line. So if you want to work out for stage 2, that's this stage here, right? That is a horizontal line. One of the key things you need to remember is that for a horizontal line, the slope of a horizontal line is 0. So if acceleration is the slope of a speed time graph, it means that the acceleration in this section here is going to be 0. So for stage 2, your acceleration is going to be 0, and acceleration is given by meters per second squared. So that's the acceleration in stage 2. In stage 3 now, you want to work out the slope of this line here. Now you can go ahead and use y2 minus y1 over x2 minus x1. But what I normally tell students, when you are doing these kinds of questions, there's a faster way to do this. So slope is really a change in y over your change in x. So in this case here, if I go to the graph, my change in y, right, that's the height of this here, is actually 12. So this is going to be 12 here, divided by the change in the x, which is this. Now that change here is, you have to subtract these two numbers here, okay? Because that's, if the starting point is 32 and the end point here is 40, it means that that change in x is actually 8. So this is going to be 8 here. But because of how this line is sloping here, this line here, it is going to have a negative slope. So just put a minus sign here. Now this is a quick way to work out a question like this. So that's minus 12 over 8, which is going to be minus 3 over 2. Yeah. So this is going to be minus 1.5 meters per second squared. Now the question asks us for acceleration. So acceleration can be positive or negative. If they had asked you what is the deceleration, then all you're going to put for them is 1.5 meters per second squared. Okay, so a deceleration is simply a negative acceleration. Now I'll do the acceleration for stage 1, even though they have not asked me that here, because I want you to be able to do this. So if I want to work out this slope here, right? So that's stage 1. So stage 1, again, the acceleration is the slope of the line. So that's change in y over change in x. So if I look at the graph here, your change in y is this height, which is the same 12. So this is 12 over the base here, which is 16. Okay, now based on how that stage 1 line is looking, it has a positive slope. So this is going to be 3 over 4. So that's going to give us 0.75 meters per second squared. Okay, so bear that in mind that you could be asked to find acceleration, right? You could be asked to find acceleration. All right, somebody's asking what's the delta. So you see that little triangle there? It means change, right? That means change. That's what that means. Okay. You see, I don't want you to try to, so you could work out the slope like this. You could have used the formula y2 minus y1 all over x2 minus x1. You can, right? Nothing wrong with that. I'm just trying to show you a faster way to work it out. Okay. Some people ask me where I got the 8 from. I need to know this length. If I want this length here, I have to take 40 minus 32. Okay. Now that is one thing they can access in a question like this. What they can also access in a question like this is what's the distance traveled. So that's not part of the question, but I will still do it. Let me get a copy of the graph here. let's see, because this is an exam question from CXC here, but let's see what else they could ask me. In this question here, they could have asked me what is the distance travel. Okay, what's the distance travel, let's say in the first 16 seconds, or the distance travel in stage 1. So the distance travel, right, let's say for stage 1. So if you want to work out distance travel from a speed time graph, all you need to do is to find the area under the graph. So all you need to do is to find the area of that triangle. So that distance travel here is simply going to be a half. It's a triangle, so it's half base by height. So half by 16 by 12. Okay, so they could have asked you that. So that's going to be 12 eighths, that's 96 meters. So that's stage 1. For stage 2, they could have asked us to work out the distance in stage 2. And all we need to do, we need to work out the area of this rectangle here. Now here you have to be careful. So the height of the rectangle here is 12 multiplied by the base. Now the base is from here to here. So you need to take 32 and subtract 16. So that's going to be 16 here. So this is going to be 12 by 16. And that's going to be 192. Right? That's going to be 192 meters. So that's stage 2. The next thing we're going to do now, we could be asked to work out the distance travel in stage 3. In which case here, your distance is simply going to be equal to this area. So you have a next triangle here to work out for. So this is going to be a half by the base. So we knew the base from before. This is 8 again. So this is multiplied by 8 multiplied by the half. By the height, which is 12. So this is going to be half of 12 is 6. 8 6 is a 40. So this is going to be 48 meters. So these are things they could potentially ask you from a graph like this. You can work out the distance travel in stage 1, stage 2, and stage 3. They could ask you all of that. What they can also ask you in a question like this here, they can ask you what's the total distance travel. So total distance travel, right? That's a possible question that could be asked. So all you need to do is add up all the areas or all the distances you worked out. So 96 plus 192 plus 48. And we're going to add that up there. So that's going to be 192 plus 96 plus 48. And you're going to get 336. So that's your total distance travel. Now, apart from asking you total distance travel, CXC can also ask you to work out here. Work out what's the average speed. So average speed is simply going to be your total distance. You all need to know this formula, right? It's total distance, right, divided by the time taken to do this. So the total distance travel is 336 meters. And the total time to do all of this is 40. So therefore, the average speed is going to be 336 divided by 40. And we're going to get 8.4. All right. And this is meters per second. Right. I hope that making sense. Yeah, you could have used the trapezium rule, right? Yeah, you could have used the trapezium rule if you want, right? Yeah. Some of you all asked about physics. Yeah, so this is something that we can get in the physics exam as well. Okay, we can get this in the physics exam as well. One thing, when you're working on the average speed, to know if your answer is correct, it is going to be less than the maximum speed for the entire journey. So if you work it out and you get something like 14 as your answer, it means something is wrong, right? Something is wrong there, right? Somebody asked me where we get 8 from. Which 8 we talking about? The 8 we got is from the 40 minus 32, right? I assume that's where you're asking. All right. Right. Let's look at this next question in this paper here. Right. So at least if you get a speed time graph, you know what to do. Okay. These are all the questions they can ask you from a speed time graph, honestly. All right, let's look at a little circle geometry here. I know some of you are struggling with these kinds of things here. So we have a circle here. It has a center O and the points A, B, C, D line on the circumference of the circle. A straight line passes through the points A and B. Write down the mathematical names for the straight lines BC and OA. So BC is this fella here. So that line doesn't pass through the center of the circle, but it touches 2 points on the circumference. So this line here is what we call a chord, right, on the circle. We want to know what is OA. So this is OA here, right? So that's from the center of the circle to a point on the circumference. So therefore, this has to be a radius. Okay, so this here is a radius of the circle. I know if you all get an easy question like this here, everybody should get that correct, right? The next part, we want to work out what is the value of x and what is the value of y. All right, so that's what we want to work out. What's the value of x? And we also need to work out the value of y. Right, now this one here is a pretty easy circle geometry. I might do a little complicated one later on. So we want to work out x and y. So let's start with x. So the first thing, if you want to work out x, we can look at this triangle here. So this here is from O to A, that's a radius. This O to B here is also another radius. So what that tells you is that A, O, and B is an isosceles triangle. So this is something you have to look out for, right? It's an isosceles triangle, great. So now, what can we do with that? Well, you know this angle is 37 here. So that tells us that this angle here is also 37. Because remember, in an isosceles triangle, we have two angles that are equal and we have two lengths that are equal. So if you want to work out angle x here, all I need to do is to say 180 degrees, because the sum of the interior angles of a triangle is 180. So it's going to be 180 minus 37 plus 37. Okay, so in this case here, we're going to get 180 minus, open brackets, 37 plus 37. And we're going to get 106. Okay, so this angle x here is 106 degrees. Now, let me ask a question here. Could anybody tell me in the chat what is angle y? Anybody know what is angle y? Right. I've seen a lot of people saying 37, some people saying 41. Now, this particular question, you have to be careful. You see some of you are looking at it and thinking, well, there's a rule that says angles in the same segments are equal, right? Now, here's the problem. We're not 100% sure, right? Some people, if you take this line OA here and we extend it here, we are not sure if you're going to end up at C. We don't have enough information to make that assumption. The only thing that we do know is this. You see this line here? This line here, BD, it passes through the center of the circle. So I know that's a diameter. If I try to use the ends of a diameter and create an angle, this angle here is going to be a 90-degree angle. I know that for sure. That's one of our roots. So if I look at the triangle BCD, I can say that angle Y is simply going to be 180 degrees minus, so we need to remove the 90 and you need to remove the 49. Okay, so you see how CSEC can trick you in some of these questions here. A lot of people saying the answer is 37, but let's calculate it and see if we do get 37. It may not be true. 90 plus 49, right? And as you can see, I'm getting 41. So the answer is not actually 37, but 41. So they did the question in such a way that they kind of trick you. Okay, so the answer is 41. right? The answer is 41. All right, this next one here is on bearings. So this is a number 9. This is a number 9 question, right? I know students generally don't like bearings at all. All right, so we have a diagram here, and the diagram shows the route of a ship cruising from Palm City to Keaton and to Riverton, and the bearing of Q from P is 133 degrees, and the angle PQR is 56. Okay, so they give us some information. Now, the first part of the question, they want us to calculate the value of W. Now, there are several things you need to remember when you're dealing with bearings. So first of all, let me show something here. So let's say I were to ask you, what is the bearing, right, of, let's say, B from E, right? Let's say I would ask you a question like, what is the bearing of B from E? So first of all, when you get a statement regarding bearings, right, what is the bearing of B from E? I normally go to the from, and I'm going to draw a note line from the from here. So let's put a point here. Let's say this is A here, and I want to head towards some other location here that is given by, let's say, B, right? So I want to go from A to B, and I want to know what's the bearing of B from E. So again, the from A tells you where to draw the note line, because a bearing is measured like this. You draw a note line, and what we do, we measure a bearing going in a clockwise direction. That's how you measure a bearing. So if you want to know the bearing of B from A, we're going to put a note line by A here. So you're going to label this with your note line, and you're attempting to go to towards the point B. So draw a line joining A and B, and the angle or the bearing that they're looking for here is this. You see this here? That's the bearing that we're looking for here. You need to understand that concept first before you can do any question on bearing. Okay? You need to understand exactly what does a bearing mean. All right? So this is what a bearing is. If I were to ask you, let's see, let me ask the next one. What is the bearing right from, bearing of E from B, right? Let's say I would have asked you this, and I have 2 points here. I have A here, and I have B somewhere down here, right? And I want to know what's the bearing of A from B. So again, what you need to do, you need to understand where we're coming from. We're coming from B. So what that means is that we're going to draw a note line at the point B, right? That's the objective. We need to draw a note line at the point B here. So you're going to draw a note line here, all right? So you put your note line, and where are you going? You are going to the point A. So you're traveling in this direction here. So what you're going to do now, since you have a line joining A and B, the actual bearing is going to be this. You're going to measure from your note line, and you're going to move in a clockwise direction. So you see from here to here, that is the angle that they are looking for. Okay, so that's the bearing of E from B. Okay, so I hope that makes sense. Okay, if you don't understand that concept, bearings is going to be difficult for you guys. Okay, now let me just tell you something else regarding bearings. So there are a few little techniques that we use when we're doing bearings, and these techniques are like this. So one of them, if I have a note line here, right? Let's say I have 2 points. Let's say this is A and this is B here. I have a note line here as well. One of the little things that we use when it comes to these things here, we're going to use the fact that note lines are actually parallel lines. So every note line that you draw on your diagram, they are going to be parallel lines, right? All of them. So in this case here, there is a rule regarding angles that I could use. So you see this angle here? Let's say we call this angle A, and we call this angle B here. There is a relationship between those two angles based on the fact that the two note lines are parallel. So those two angles are what we call supplementary angles, and they actually add up to 180 degrees. So this is one of the tools that I would use when I have to work out some of these things, right? So the trick here is to remember your knot lines are parallel, and there's a relationship between those two angles there, right? Let's go on to, so that's one rule that I make use of a lot when I'm doing bearings question. Another rule that I use as well, let's say I have a knot line here, right? I have a point here, and I have other pieces of information. I have a line here, I have a line here, okay? What I do as well in some of these questions is that, let's say we have this angle here, this angle A, let's say this is angle B, and let's say this is angle C here. There is a relationship between all of these angles, right? Because all of these lines meet at that point in the middle here, then I can say that A plus B plus C is equal to 360 degrees. Okay? Now, this is one thing that I use when I'm trying to solve questions involving bearings. Okay? So keep that in mind. Those are two little techniques or two little tools that I can use when I'm solving these problems. So since you have an idea what a bearing is now, let's go back to the question. So they told us a bearing of Q from P, and it's 133 degrees. And they gave us this angle 56 here. So now I want to calculate angle W. How do I calculate angle W? Well, you will notice that this is a knot line, and this here is also a knot line. I just literally gave you a rule I can use here. If that is 133, it means that this angle here, I can actually work that out. Because the 133 and that angle, they are supplementary. They're going to add up to 180. So this angle is simply going to be 180 minus 133. So 180 minus 133 is going to give us 47 degrees. Okay, so that angle there is 47 degrees. Now we want to calculate angle W. But if you notice here, they drew the knot line as a vertical line here. So that means that when I add up the 47 plus the 56 plus the W, I should get 180. So therefore, this angle W is simply going to be 180 degrees minus, so you have 56 to remove, and then you have the 47 to remove. So when I work this out, I'm going to get my angle W here. So that's 180 minus, open brackets, 56 plus 47, close brackets, and we're going to get 77 degrees. Okay? I don't want you to chat. I don't know if anybody gets 77. Right? I see people talk about grade ones. Yeah, it always aim for grade ones. That's what you're aiming for. All right. Some people, they set the target a little low and the objective is just to pass. If you're okay with that, that's fine. All right. But students in my class, I normally tell them, here, what we aiming to get grade ones. That's what we're aiming for, right? Somebody's asking about the reason. Yes, when it comes to circle theorem, guys, usually they will give you marks for your answers, right? Your reason for your answers. That's what they normally do. They have to give you marks for this, right? So if you have to calculate an angle in circle theorem, you might see 2 marks. And if it's 2 marks, one of the mark is given for your reason. Okay, so just bear that in mind. Right, somebody's asking what a grade 1. I can tell you for a fact, grade 1 is not no 80 and over, right? I don't believe that at all. All right, I think it's lower than that. And I can tell you that based on the results of my students, I normally give them assignments and I know what they get at the end of it, right? Whether they get a grade 1 or not. And I am sure that a grade 1 in maths is not 80. It's less than 80. Okay. Okay, so what else I have here in this question? So we have to calculate that. And the next part, they want the bearing of P. Now let me see if you all paying attention here, right? Read this question carefully and let me see what you think the answer is. Determine the bearing of P from Q. What is the bearing of P from Q? All right, I know I know watching the chats here. Explaining good. Yeah, I'm the boss at explaining maths, right? What grade did I get in maths? I've got a grade 1, obviously, with all E's. Right? What about the bearing, guys? What about the bearing here? What? Right? So I'm glad that you guys are paying attention. All right. Sometimes people jump into live and they just come and they're here to cause chaos. Right? Everybody's here to learn. All right. So just stay focused. Just listen to what I'm saying and you'll be okay. All right. Pay attention. Pay attention. People saying 313. Some people. Okay. So I've seen a set of different answers here. Let's see. So first of all, let's understand the bearing. Understand what they're asking us. So you want the bearing of P from Q. This is what I'm telling you how I reason these questions. So we're starting from Q. So let's come to Q here. Right? You're starting from the point Q. And where you going? You are going to the point P. So that means you're traveling in that direction. Okay? So really and truly, this is what you have here. So you have, if I can draw it here for you. So this is Q. Sorry, this is P. This is Q. Right? This here is your north line. So we're trying to head to point P. So think about it, how we define a bearing. This is your north line here. So if you want to get a bearing of P from Q, it means they're asking me for this angle here. Okay? So if I look at the diagram here, the angle that they want is all of this. Right? I don't like how that's looking. Hold on. Right? They want all of this. Right? That's the bearing that they're looking for here. Once you identify what that is now, so that bearing is, so you see this piece on this side here, that is actually 180 degrees because that's a straight line. So this is 180 degrees plus we have to add the angle W, which is 77 degrees, plus we have to add the 56 degrees here. So when you add this up here, you're going to get 180 plus 77 plus 56, and we're going to get 313 degrees. So those of you who said 313, yeah, that makes sense to me. Yeah, some people say they thought that grade 1 is in 90s. Never, right? I can tell you that is not true, right? Right? If that was true, guys, if that was true, then out of the whole of CXE, they probably would have gotten maybe 100 students getting grade 1s. All right? So don't believe everything you hear out there. All right. The next thing that we want to calculate the distance RP. So let's see how we doing that. Honestly, somebody's asking about a grade 3. I feel like a grade 3 could be around 55, around there, right? It could be a little lower because as far as we know, CXE looks at the scores of everybody and then assigns grades. As far as we know, there's no fixed grade threshold. So it means they're going to look at everybody's score and adjust that threshold every year. All right, we want to calculate the distance RP. So where's RP now? RP. All right, I'm just going to take a little copy of this here. Okay, so this here is our diagram, and we want to calculate the distance RP. So first of all, let's not clutter, right? I don't want you to clutter yourself here. I'm just going to sketch this over. So I have P, I have Q, and I have R somewhere, right? So I have this, and I have this. Okay, so this here is P, this is Q, and this is R. Okay, on the diagram, I have some numbers here. This is 210 kilometers. This is 290 kilometers. And this here is 56 degrees. Okay, and the question wants me to work out the distance RP. Now, whenever you get in a question on bearings, most of the times we're going to have to either use the cosine rule or we're going to have to use the sine rule. It's going to be one of them. Okay, now some students, they are not sure when to use the sine rule and when to use the cosine rule. So let me tell you something here. When you are using the cosine rule, so this is something you need to know. When it comes to the cosine rule, Okay, there are two conditions under which I can use the cosine rule. And the cosine rule and the sine rule, we use them when the triangle is not a right angle triangle. So for the cosine rule, one scenario is this. If you have two sides, so let's say I have this side, let's say this is A, this is B, and I know this angle, I can use the cosine rule. So you must have two sides, and you must have the angle in between the two sides. So you must have this. That is scenario one when I can use the cosine rule. So we don't guess, right? There's no guessing game when it comes to selecting which rule to use. In this case here, if I look at this question here, I have the 210, I have the 290, and I have the 56. So therefore, I can use the cosine rule. Now let me tell you the other conditions under which, or the other condition under which I use the cosine rule. If in a triangle, right, again, we're looking at triangles that are not right angle. If you know this length, you know this length, and you know this length, and you want to work out, let's say, this angle, you want to work out that angle, okay, you're going to use the cosine rule here. So in the cosine rule here, you could be given all three sides of the triangle and no angles. So that's the second condition under which I use the cosine rule. So two sides and one angle in between, or if I have both sides, not both sides, three sides. The sine rule though works like this. There are two conditions under which I use the sine rule. So to use the sine rule, I basically need two angles and two sides. That's what I need. So if I would have, let's say, this here, and I had, let's call this angle A, and let's say I had this side B here, right? So let's say I had two sides and an angle. One of the things you have to remember with the sine rule is that we are relating sides and the angle which is opposite. Okay, so if I wanted to calculate, let's say, this angle here, I can use the sine rule because I have two sides and I have an angle opposite to one of the sides. So that is one condition under which I use the sine rule. There is a second condition as well, and that second condition looks like this. If I have two angles, so let's say I have angle A here, and I have angle B, okay, and I have one of the sides, right? And one of the sides has to be opposite the angle, then I can use the sine rule. So the trick with the sine rule is to make sure that whatever sides you have and whatever angles you have, they have to be opposite each other, okay? So let's go back to the question, right? I know I'm shifting gears ever so often. I'm just showing you things that could potentially appear. So first of all, let's see how we're going to use this cosine rule here. So when it comes to the cosine rule, where you have two sides and an angle, what you should do is to label this, right? So you know which side is opposite the known angle. So using the cosine rule, right? So we're using the cosine rule here. Now, first of all, lots of students, and by the way, the cosine rule is actually given to you guys in the exam. The cosine rule is actually given to you in the exam. But when you get the cosine rule, a lot of students have no idea how to use it. So that's why when I'm teaching my class, I teach my students, look at the triangle, and you're going to work out the answer without necessarily writing down the cosine rule formula. Because this is what it looks like. Cosine rule looks like this. C squared is equal to A squared plus B squared minus 2AB cosine of big C. When you see this formula here, lots of students have literally no idea how to do this. Okay? So in this case here, what we're going to do, we are going to apply the cosine rule based on the triangle I have here. So this side here, PR or RP, which is what they want me to work out. So you're going to say RP squared is equal to, so you're going to start off with the sum of the squares of these two sides here. So this will be 210 squared plus 290 squared minus, and it's always going to be 2 by the two sides that you know, which is 210 multiplied by 290 multiplied by cosine of the angle, which in this case is 56 degrees. So what I've done here, I'm applying the cosine rule based on the triangle I am seeing in front of me. So this is going to be RP squared. Now I normally do this step by step, right? So 210 squared, you're going to get 44,100. So 44,100 minus let's work out this as 2 by 210 by 290 by cosine 56. You're going to get 681, right? I'm going to round it off here. 68110, right? I'm looking correct. 681. Yeah. So therefore, RP squared is equal to, so that's 44,100 minus 68,110. That's not something looking wrong. I missed out something clean. I work out 210 squared, right? I still need to work out 290 squared. Right, so this is 84,100 minus, so this is going to be 2 by 210 by 290 by cosine 56. Right, so this is 68110. All right, so we get 60,090. So therefore, RP is equal to square root of 60,090. So RP is equal to second function square root, and you're going to get about 245, right? And make sure this question was in kilometers, so you have to use the same unit here in kilometers, right? Right, some people are asking about Pythagoras. Yeah, we can only use Pythagoras' theorem if it is a right angle triangle. Okay, so I can't use Pythagoras' theorem at all unless it's a right angle triangle. Okay. Somebody's asking if I have to put it to the nearest whole number. On the exam paper, they normally tell us to write our answer to 3 significant figures. In some of these questions, they might ask you for the answer to 1 decimal place. Did they say anything? I don't think I saw anything about, yeah, they didn't specify. They didn't specify. Okay, so in this case here, I'll just leave my answer as 245 kilometers. Okay. All right. I saw a lot of people asking about transformations. So let's look at 1 or 2 transformations here. Now, for your exam, there are 4 different transformations that you need to know about, right? 4 different transformations. So let's have a look at this here. So we have what we call transformations. Now, when it comes to transformations, we have what we call a translation. Okay. We also have something called a reflection. Right. We also have something called a rotation. And we have something called an enlargement. Okay. Now, the first one, a translation, is simply a movement in a particular direction. That's all it is, right? A translation is simply a movement in a particular direction. So you have a triangle, and if I shift the position of the triangle, the orientation doesn't change, the size doesn't change, and there's a particular word that we use when it comes to transformations, and that is called congruent. Okay, So if I had two shapes, let's say I had a triangle like this. Let's see. Right, I had a triangle like this, and that's an object. I have a second triangle here after the transformation, and it looks exactly the same. So all the lengths are identical, all internal angles are exactly the same. These two shapes are said to be congruent. So that's a word that you need to be familiar with. Okay. Now, in this case here, let's try translation. Let's see what could actually come in the exam. So let's see, right? You had this shape here, ABC, and we want to translate this, right? And usually this is normally a 1-mark question. Translate using a vector. Right? And let's say the vector is -4, and let's say, yeah, let's say -4, 3. Right? Let's say I want to translate this vector using, or translate this shape here using that translation vector. Now, first of all, when it comes to a translation, we normally move in the horizontal direction first. Okay? So whenever we move to the right, that number on top there, as in this number on top here, has to be positive. If that number is negative, then we are going to move to the left. The number on the bottom tells you whether you're going to move up or whether you're going to move down. If that number is positive, you're going to move up. And if the number is negative, you're going to move down. So whenever you are asked to perform a translation, you need to understand exactly what the numbers mean to begin with. So in this case here, we have this number here. So this is 4 units upwards. Sorry, not upwards. 4 units to the left, right? 4 units to the left. So the number on top tells us left, right. The number at the bottom here tells us up or down. In this case here, because it's a positive number, you are going to move up. Okay? So we need to understand what the numbers mean to begin with. So what you can do, you can start with any one of your vertices here. So if I start with A, and since I'm going -4, you're going to check 1, that's 1 unit to the left. That is 2 units to the left, right? This is 3 units to the left. This is 4 units to the left, right? So I'm checking 4 units going to the left here. So this here is -4. I'm moving 4 units that way. And then we have the positive 3. So you're going to move 3 units upwards. 1, 2, 3. So therefore, this point A here, this is going to become your A prime. Okay? So that A there is actually being translated to a new position. That's what's happening here. Now, if I want to draw that new triangle there, because that's what they want us to do, all you're going to do, once you know where A is, you can figure out where B and C is. So since this length here is 3 units downwards, this here will also be 3 units downwards. If this length here is 2 units, it means that this is going to be 2 units. So therefore, this here is going to be my translated triangle. So this here is going to be your B prime. So this here is B prime, and this here is C prime. Okay? So this here represents your triangle after a translation using this vector here. Okay? Now you don't need to put this arrow here. This arrow that I have here is not required. I'm just showing you it's a vector. That's basically what it is. It's a vector. Okay? Right? Hope that making sense. I hope that making sense. So here's what I want you to do, right? So please remember to hit like and subscribe. Share the link to the live to as much of your friends as possible, right? Let's see if we can help a lot of people today for that exam tomorrow. Okay? So that is one question they can ask you, and CSEC normally gives us just 1 mark for that, right? To perform a translation. What they can also do as well, they can give you an object. So let's say this is the object here, right? And let's say this is your image here. And they ask you to describe this translation, or sorry, describe the transformation. So if they were to ask you, describe, and these are the words they're going to use. Describe the transformation right? And they're going to say as fully, and they're going to put this in caps here, as you can. Right? Describe the transformation as fully as you can. Anybody know what this is? I will try to cover as much topics as I can today. All right. This is just the first session. All right. This session probably going till about maybe 1 o'clock. I might be able to stretch it till 1:30 maybe. Right? If you had to describe this as fully as you can, what are you going to tell them? And it's usually a 2 mark, right? It's usually a 2 mark. Describe this transformation as fully as you can. Right? So some people are saying it's a translation. All right. So like I said, this here is our free live session on YouTube here for those of you guys writing the CSEC maths tomorrow. All right. So please share with as much students as possible because they can get some help in CSEC maths for tomorrow. Right? Right. So I've seen some people saying trans. Okay, so here this is typically 2 marks. If you all just, there are 2 things CXC is looking for here. When you all say it's a translation, so first of all, to know if it's a translation, it's simply a shift in a particular direction. You will notice that the object and the image, they have the exact same size. The orientation has not changed. So therefore, it's just a shift, and that is what we call a translation. Now, it's a translation, right, using, this is what the second mark is for. You must include the vector. So using a vector, okay, so it has to be a vector, and that vector has 2 numbers in it. Now we need to figure out what those 2 numbers are. So first of all, let's select, and you can select any point you want. Let's say B. Where does B end up? B end up here. So let's draw a line from B to B prime. Okay, so this is the line here, but we need to figure out what that vector is here. So first of all, how do we move from B to B prime? Now you're always moving in horizontal direction first. Because some students, what they do, they go up and then they go across. But that's not what you're doing. You have to go across first. So we go 1, 2, 3, 4, 5. So that's 5 units to the left. And because you're going to the left, it is going to be -5. And then we're going to go 1, 2, 3 upwards. So it's going to be -5, +3. Okay. So that's the second kind of question that we can get when it comes to lines. Why need 4 lines with just a small sentence? Yeah, what you guys actually get any mark for, right? When they say describe as fully as you can, all they want you to say translation, and then they want you to give the vector. That's the 2 marks here, you know? Right? That's it. That's all they want. Okay. So that's translations. Let's say the second one, right? The second one that they want here is reflection. Now, when it comes to a reflection, you guys need to think of it as if I fold the graph paper along a mirror line, both your object and your image needs to line up exactly. So for example, let's say we had an object here, right, which is a triangle, and I want to perform a reflection. So we're talking about a reflection. Now, when it comes to reflection, there are several kinds of questions they can give us. So if I want to reflect, and when it comes to reflections, you need to know that this is called your x-axis. Sometimes CXC will ask you what's the equation of the x-axis, and this is something you have to know. So the equation of the x-axis is also the line y is equal to 0. Okay? Now, if I want to reflect that object there or that triangle in the x-axis, what I'm going to do, if we start with, let's say, the point B. Now, the point B here is 1 unit in front of the mirror. So your mirror line in this case is behaving as this line here. Okay? So picture the triangle or picture the graph paper folding along that red line there. That's what you have to picture. If I fold it, where is B going to end up? B is going to end up exactly here. So we're going to label that as B prime. When I fold again, C is going to end up right here. So this is C prime. Where does A fall? So when you fold A, right, A is actually 1, 2, 3, 4 units in front of the mirror line. So therefore, A is going to be 1, 2, 3, 4 units. So this is where A is going to end up. This is going to be A prime. So if I want to draw the image, all I need to do is to join this, and to join this. Okay? So this is a reflection in the x-axis, right? Or the line y is equal to 0. Okay? Now, when you guys are describing a reflection, there are two things you need to say. You have to say that it is a reflection, right? You'll get 1 mark for saying that. And you must also indicate what is the mirror line. If you don't have that, you're not describing the transformation as fully as you can, right? Right? It could be my internet connection, maybe. I'm not sure. Okay, so this one here is a reflection in the x-axis. What if I have that same triangle here and I want to do a reflection? So let's say we want to do a reflection in the y-axis. Right? Now, when it comes to the y-axis, so up here, this is your y-axis, and that is also known as the line x is equal to 0. Right? The y-axis is the line x is equal to 0. So you all need to know that. So the x-axis is also referred to as the line y is equal to 0. So in this case here, if I want to reflect this in the y-axis, so just remember where the mirror line is. So this here represents your mirror line. So if I want to draw where the image is going to be, you have to picture folding the graph paper along that red line. If you fold that along the red line, let's say we look at B here. Right now, B is 3 units, in front of the mirror. So therefore, when I fold the paper, that B there should really line up here. This is where B prime is going to be. This is where C is here now. If I would have folded it, right, what's going to happen is that C prime is going to be here. That's where it's going to be. If we look at A is actually 5 units in front of the mirror. So therefore, it has to be 5 units behind the mirror. So therefore, it's going to be here. That's E prime. So if I were to draw so this is your object. So your image is going to be this here, right? So we do this, come here, all right? And we do this, right? So this here represents your image after it's reflected in the y-axis. So again, if you had to describe this, you're going to say reflection. That's your 1 mark here. And you need to specify your mirror line. That's your mirror line. Okay? Hope that makes sense. Okay, right, so Now, what if, let's say we had to reflect, right, in the line, right? Let's say x is equal to 2, right? That's a potential thing they can make us do in the exam. If I want to reflect this triangle in the line x is equal to 2, the first thing you're going to do, you need to draw the line x is equal to 2. Now, when you have to draw a line x is equal to something, it is a vertical line. X is equal to something is a vertical line. So what you're going to do, you're going to draw the mirror. So this here is going to be the mirror, right? And if you notice, it's passing through x is equal to 2. So this mirror line here is x is equal to 2. And if I want to reflect it in that line here, then we start off with any one of the points. So this is going to be B prime here. C is going to be 1, 2, 3 units behind. So that's 1, 2. So this is where C prime is going to be. A is going to be up here. That's A prime. So therefore, when I join this, I'm going to get this here. And we have this here. Okay. So your image after this reflection in the line x is equal to 2 is going to be this. That's your reflection here. Okay. Now you can identify a reflection because what you can do, right? What you can do, if you want to know if something is a reflection, look at the object and the image. Try to bring them together like this. Just like if I'm taking my left hand and my right hand, and if I bring them together, they don't overlap, right? They don't line up exactly at all. The only way they line up is if I fold it so that my left hand and my right hand, they line up, okay? Some people are asking if the session is recorded. Yes, it is being recorded, right? It is being recorded. So let's take a note of the link because sometimes YouTube, it doesn't necessarily show the recorded session, but if you hold on to the link, save the link, and you can get back to the class if you want, all right? So this here is a reflection in the line x equal to 2. So what you all need to remember is that when x is equal to some constant or some number, it is always going to be a vertical line. You need to remember that. Let's see, right? Let's say I had this triangle here. One of the things that CSEC can ask me to do is to reflect, right, in the line y is equal to x. Okay. Now, when it comes to lines, you all need to know certain lines for the exam. So first of all, if I have x-axis, y-axis, okay, this straight line here, right, is the line y is equal to x. This line across here, okay, is the line y is equal to negative x. These are lines you need to be familiar with. Your x-axis is the line y is equal to 0, and your y-axis is the line x is equal to 0. When it comes to reflections, these are things you should remember. Okay, so let's say I want to reflect this triangle here in the line y is equal to x. So first of all, right, y is equal to x will pass through right? So this here represents the line y is equal to x. So you could be asked to perform a reflection in that particular line. So first of all, let's reflect the point B. Now, when you're reflecting in your mirror line, you see this line that I draw between the mirror line and B? That line here has to be a right angle. Yeah? So if I continue with that line here, what's going to happen is that B is going to end up here. This is your B prime. We're going to do the same thing with A. If I reflect the point A, A is going to end up at this point here. So this is going to be A prime. When it comes to C now, what's happening to C? So C, right, is going to end up at this point here. That's C prime. So if you notice, all of these lines that I'm drawing here, they are all meeting that mirror line at 90 degrees. So if I were to draw my image, this here, right, is going to be my image after I reflect that triangle in that line y is equal to x. So this here is your image. All right. I've seen people asking about rotation. Yeah, no problem. We're doing the rotation next. Go study that. Right? So that's our third thing that could come in the exam. So that's a reflection. Okay, so it's easy to spot a reflection. Now, let's see, right? Actually, let me see where you are. Right? Now, if you are asked to describe this transformation as fully as you can, okay, let's say you have to describe this translation as fully as you can, how are we going to do that? All right. So first of all, to know if something is a rotation, what you're going to notice is that the object and the image, they have the exact same size. Okay, the object and the image, they have the exact same size. And let's see, right? So we can tell if it's a rotation or not, right? Now, if you have to describe a rotation, there are several things CXC wants here in order for you to get the full marks. So if it's a rotation, you must specify it's a rotation, yes. We have to see if it is clockwise, right? Or anti-clockwise. All right. We have to see what is the center of rotation. Right? And we also have to specify what is the angle. Okay? What is the angle? Now, for your knowledge, CXC will generally give us angles that are 90 degrees, 180 degrees, or 270 degrees. Okay? It's always going to be a multiple of 90. They're not going to give you 25 degrees and say do a rotation. Okay? They're not going to do that. Okay? Somebody's asked about pencil. Yeah, you can do these questions in pencil. Right? These questions can be done in pencil. Okay, now let's see. Now let me show you a little trick here that we're going to do now, right? I'm going to take this diagram here. Right, now I'm not sure if you're going to see my screen here, but I'll try my best. Okey-doke. So I believe you all are seeing my screen, right? Hopefully. So let's say I wanted to determine, so we know it's a rotation, right? Now some students are going to look at this and they're going to say, all right, it's a rotation and it's looking like a rotation of 90 degrees anti-clockwise about the origin. Now let me show you a little trick that you can do here. So if you all think that the rotation is about the origin, you can do a little test with your compass, right? So let's say I'm going to open my compass here and I'm going to open it to, let's say, the point A, and we're going to do a little test, right? Now, what this test involves here, if we're thinking that the rotation is about A, then if I were to take my compass and I were to put the pointy part by the origin and I were to do this, let's see what's happening here. You realize, wait, something wrong. A prime should be on that line, okay? So those of you thinking it's a rotation about the origin, that is not true, okay? Because if that is true, when I select this point, the origin here, what is supposed to happen is that A prime should lie on that arc there, okay? Now, ever so often, CXC might give you questions like this here. You can tell it's a rotation, right? You can definitely tell it's a rotation, but I don't know what the center of rotation is, okay? Now, there is a technique that we can use in order to work that out. So what you do, you're going to draw a line, let's say from B to B prime. So that's one line that you can draw. You can also draw a line from, let's say, right, I hope I have enough space to do this, yes. Right, so this here is A to E prime, right? So that's the first thing you're going to do. You're going to join two corresponding points. And then what we're going to do, we're going to find the perpendicular bisector of each line. So let's start with our compass again. And what I'm going to do, I'm going to find the perpendicular bisector of that red line. Okay? Now here's what you need to do. You need to open your compass to more than half the length of the line. That's how we work out, or that's how we determine perpendicular bisector. So what I'm going to do, now a question like this, the diagram gets complicated. Eh? So I'm going to draw an arc here. You're going to take the compass, come to this other pointy part here, and we're going to draw a second arc. All right? So you're going to do this. You're going to draw a second arc here. So what I'm doing here, I'm trying to find the perpendicular bisector of that red line. So what you're going to do, right? So this is what I'm doing here. Right, so let's draw our, so this line here, right, that I'm drawing here is the perpendicular bisector, right? That's the perpendicular bisector. Okay, so let me label this for you here so you understand what's happening. So this here, this line here is the perpendicular bisector. Right, that's the perpendicular bisector of the red line. Now we have to do the same thing for the blue line as well. So let's switch here now and let's deal with the blue line. So to deal with the blue line, we're going to take our compass. Now I'm not sure, I hope I have enough space to draw this here, right? So we're going to start with E, right? And we're going to open the compass here, right? I wonder if I could really get this thing to fit, right? I may run into a little trouble here, right? But let's see if I can do it. So we're going to find the perpendicular bisector of the blue line, right? So we're going to draw an arc here, right? So hopefully that works. Then I'm going to come to the point A here, right? And you're going to draw a next arc. So we're going to do this. Ooh. Right? 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 I don't think I have enough space. So here, what I'm going to do, I'm going to just estimate, right? I'm going to estimate where this thing is going to be, right? And kind of draw it a little body. Right? So I need to figure out, let's see. Right? I feel like it's gonna do a guesstimate here for you, right? Right? I just want to test something here first, right? Okay, yeah. So let's go back to this blue line. Right? I'm going to assume it's in this direction here, right? I'm going to assume that this here is in that direction, right? So I have the two perpendicular bisectors. Now I know the diagram gets a little complicated. So what we're looking at here, so this is our second perpendicular bisector. This one here, this blue line here is our next perpendicular bisector. So you're looking to see where this line and where this line intersect. You will notice that if both of them intersect at that point there. That there represents our center of rotation. Now, if you think that's the center of rotation now, then all you need to do is to take a compass again and do a double check. So if I were to take my compass here and if I were to take my compass here and let's open it to the point A, right? So let's say here, that's the point A. Now let's rotate this here. Let's rotate this here and see if it passes through A. You'll notice that it does. It does pass through A prime. Now let's check it for maybe C as well. Right? Let's check it for C. So if I do this here, you will notice C and C prime, they actually line up. So that's good. Right? So far we're looking good. And then let's double check it for B. So if I were to check for B here, you realize, hey, B and B prime passes through the same arc. Okay? So if you had to describe this transformation as fully as you can, right, as fully as you can, I've just worked out, right, I've just worked out what the center of rotation is. So that center of rotation is given by -1, right, and 0. That's the center of rotation. So let's go back to, let me go back here now. Right, so let's go back here. So if I want to describe this thing here as fully as I can, right, as fully as you can, in this case here, we're going to see, right, it's a rotation. So it's a rotation, right, and we have to specify what angle it is. Now, if you look at the diagram I have here, right, since we're saying this is the center of rotation, -1, 0, to figure out the angle, all you need to do, you can use this point and B prime, and maybe this point and B. And if you look here, this angle here is a 90-degree angle. So what is actually happening here is that this whole triangle is rotating this way. So it's a rotation, right? 90 degrees. You have to specify direction. That's anti-clockwise. Right? And we have to say about the point. What's the center of rotation? So it's about the point, right? And that point is this here, right? Which is -1 and 0. So when it comes to a rotation, you have 4 things that you have to see in order to get the mark, right? There are 4 things I need to see in order to get the mark, right? But somebody said they're going to put a reflection. If you put a reflection, you get a fat 0. Once you see a change in orientation, at least put down the word rotation. You'll get a little mark for that, right? Right? Now, some of you all, you saw me do the construction there, right? But if you want any exam, you can figure that out by just using your compass here. If you kind of guesstimate where the center of rotation is, you can use your compass to figure it out. Okay? Under exam stress there, and you can't figure out how to work it out. That's all you do. All right. Now, the 4th kind of transformation that we can get in the exam, the 4th kind of transformation is called an enlargement, right? It's called an enlargement. So if I have to describe, right, the transformation, right, as fully as you can, right? Let's say we had to describe this here. So first of all, when you have a scenario like this, so this here is your object, right? And this here is your image. And we want to figure out what kind of transformation is this. So first of all, you can tell that there's a difference in size, right? So we know it's definitely an enlargement. Now, you're not just going to put enlargement alone. That is only going to give you 1 mark, right? So you have to specify, yes, it's an enlargement. It got bigger, okay? But when it comes to an enlargement, we need to give what we call the scale factor. So the scale factor, or what we call K, right, is equal to, so K is simply equal to, all you need to do is to measure 2 lengths. So for example, if I measure this length here, that length there is 4 units, right? That's on your image. And you're going to measure that same corresponding length here on your object. That is 2 units. So 4 divided by 2. So the scale factor is 2. It means that my lengths are increasing by a factor of 2, right? Now, what else we have here? So we know the scale factor. We also need to specify the center of enlargement. That is required in your answer as well. Center of enlargement. Now, the center of enlargement is a coordinate. How do we do that? Well, all you need to do, you're going to draw a line here, right? From A to A prime. So you're drawing this projection line here. Okay. Should I use? Let me not use that. I'll actually use a line here from PowerPoint, right? right? So that's one line here. We're going to draw another line from, let's say, B prime through B, right? We're also going to draw a third line, right, from, let's say, C to C prime. Now, what is supposed to happen here is that all three lines are supposed to intersect around the same point. Okay, that is what is supposed to happen. Now, because I'm trying to draw this here on the fly, I may not get them to line up exactly, right? But I'm going to make it line up. Right, so what you're going to notice is that all these lines or these projection lines here, they meet at this point here. This coordinate here is positive 10. Right, this is 10 and this is negative 2. Right, 10 and negative 2. So the center of enlargement here is going to be 10 and negative 2. So guys, you want to get your marks for this here to describe the transformation. Yes, we know it's an enlargement. Yes, we must indicate the scale factor. And you must specify the center of enlargement. If you only say enlargement there, you're only going to get 1 mark. Yeah? Only 1 mark. Right? So that's 1. Okay. Now, what CSEC can do as well, they can give you a center of enlargement. They can give you an object. They can give you an object here. So this here is an object. And they want you to draw the image, right? But they could also specify what the scale factor is. So let's say we want to do an enlargement, but I give you a scale factor of, let's say, 1/2. And you want to perform this enlargement here. So to do that, all you need to do, you need to draw your construction lines. So let's come here. Now you know what the center of enlargement is. It is a point P. So you're going to draw a line from P here, right? And you're going to pass through each of these points here. Okay, that's what you're going to do. So in this case here, let's, from P, you're going to pass through the point C here. You're going to draw next line here. Right? So now, we need to locate where this image is going to be here. So since we have a scale factor of 1/2, what is going to happen is that your image is going to lie between the center of enlargement P here and your object. So how are you going to locate that? All you need to do, if you look at this line here from P to A, all you need to do is to find where's the midpoint of that line there. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So this is where A prime is going to be. A prime is going to lie right here. Okay. Now, we need to locate where is C prime going to be. Now, the thing is, if I know the point E and it's an enlargement, I know that C prime should be on this line here. So C prime has to be on this line here. The point B prime has to be on this line. So it has to be located at this point here. So this here is your B prime. So therefore, if I were to draw this image here, it is going to be this, and it's going to be this. Okay. So your image in this case here, if I use the center of enlargement as a point P and my scale factor is 1/2, this is what we're going to get here. Okay. All right. So some of you guys asked for transformations. I just wanted 2 questions on transformations. Right. Some people are asking about mode, median, and those kinds of things. So hold on. Right, now what we've noticed over the years, CXC loves to bring questions on cumulative frequency curves. So let's have a look at this question, right? So a group of 100 students estimated the mass M of a seed. The cumulative frequency curve below shows the results. So we have some data here, and there are several things that we want to calculate. So we want to calculate what is, first of all, the median, 1 mark. All right, so we want to calculate the median. Now, the median is the middle of your data if I arrange my data in ascending order. All right, so the first thing we're going to do in this question here, we need to know how many students do we have. So in this case here, n is equal to 100. Now, if you want to work out where the median is, all we need to do is to find half of the 100. Half of the 100 is going to be 50. So what we're going to do, we're going to come here and we're going to read off where 50 is. So if I want to read this off here, right, 50 is not the median, by the way. Some students think it is. But you're going to come here and then you're going to come and read this line going down here. Okay, so that is going to correspond to your median. In this case here, that is actually 3.2. So this median here is 3.2 and our unit here is going to be grams. So it's 3.2 grams. Okay, now the next thing that we want, so there are a few things I want here. So they want the upper quartile, right? And they also want us to work out the semi-interquartile range. Right, so upper quartile. Now, if you want to work out the upper quartile, all I'm going to do here, I'm going to find 3/4 of the 100, okay? And in this case here, you're going to get 75, right? But 75 is not the answer. You're going to read off at 75. So again, let's come to the graph. And then all we're going to do, right? All we're going to do here, we're going to draw a line. Right, so we're going to draw a line here at around 75. Right, now this graph here is a little twisted. So I'm going to have to kind of right, so we're going to have to kind of read it off like this. So you read it off at 75. Right, so that might be about 4.4, right, for the upper quartile. So I'm just estimating here. The graph a little twisted, so it's a little difficult to draw a straight line here. Okay, so that's your upper quartile. You read off at 75 in order to determine the upper quartile. Now, if you want to work out the semi-interquartile, so the semi-interquartile range is going to be a half your upper quartile, which is Q3, minus your lower quartile. Now, you already worked out your upper quartile. This here represents Q3. So we still need to figure out Q1 in order to do this here. So this is going to be a half multiplied by 4.4 minus. Now to get Q1, that's the lower quartile, you just have to read off at a quarter of 100, which is 25. So let's draw a line here at 25. Right, but like I'm telling you, the graph here is a little off. So right, so I'm just going to estimate that as maybe 2.2 around there, right? I'm just going to say Q1 is about 2. So let's say that's 2.2. So in this case here, that's going to be 4.4 minus 2.2. I'm going to divide that by 2, and we're going to get approximately 1.1 gram. Okay, so cumulative frequency, like I said, is something that they love to bring in the exam, right? They like to bring this in the exam. Right, so semi-interquartile range, and the last thing they have here, part 4, they want you to determine the number of students, right? Determine the number of students. Right? They want the number of students whose estimate is 2.8 grams or less, right? 2.8 grams or less. Now, when it comes to a cumulative frequency curve, the curve only gives us less than information, right? The curve only gives us less than information. So what I need to do, I need to read off at 2.8. So you go back to the graph, you're going to draw a line again, but you're drawing a line now at 2.8. So that's going to be around here. Right, and that looks like, so you need to read that off there. So that's about 38. So that's about 38 students here. Right? Now the next part is a part that tends to give students a little trouble. All right, so they said use a cumulative frequency curve on page 8 to complete the frequency table. Now, CSEC has brought a question like this on more than one occasion, right? More than one occasion. And students have had some trouble when it came to this, okay? Now, basically, a cumulative frequency curve gives us all the cumulative frequencies. However, we are working backwards here now to figure out what is the frequency, okay? So your curve will give you cumulative frequency. Now, sometimes when you are given group data, so sometimes you see group data like this, 0 to 5, 6 to 10, right? 11 to 15, and so forth. When it comes to these kinds of data here, what happens here is that your upper class boundary for this will be 5.5. The upper class boundary for this will be 10.5. The upper class boundary for this will be 15.5. So this is, when you plot cumulative frequency, we use upper class boundary. However, in this particular question here, they have written this here, your interval, as an inequality sign. So if I were to ask you, what is the upper class boundary here? You're going to just tell me 2 is the upper class boundary, not 2.5. The upper class boundary for this one here is going to be 4, not 4.5. Okay, so this is one way group intervals can be given, and they can also be given in terms of an inequality here. So what you need to do, you need to go to the graph. So the upper class boundary, let's read off some values here. Let's read off our cumulative frequencies here. So 2 corresponds to 20. The cumulative frequency was 20. Let's see what 4 corresponded to. If I go to the graph there, 4 looks like it's corresponding to maybe about, let's say 60, maybe 68, I guess. Right? That's maybe 68. For the next one here, let's read off at 6. When I read off at 6, I'm getting about 92, maybe 90. It looks like about 93. Right? The next one here is 8. Let's see what we get for 8. If I read off at 8 there, that looks like about 90, maybe 99. Right? And then, well, the last one will be 100. Okay? Now, let's check something here first of all, right? So, if we look at the data here, right? So, you have cumulative frequency from your graph itself. Now, you're working backwards to figure out what your frequency is. Now, if this is the original frequency here, and your cumulative frequency went up to 68, it means that you would have added 48 more in order to get that 68. if I want to go to 93 now, the amount that I need to add now will be 93 minus 48, and you're going to get 45. Okay, so this is what's happening here now. So 45, right, will be for this one here, because make sure I tell you this correct. Okay, hold on. Right, so 48, we get 68. Right, so this is 45, right? $20 plus 48. Oh, sorry. This is not correct. So what you're doing here, right? If you remember how you work out cumulative frequency. So your first row, right? You'll get a cumulative frequency of 20. When I jump to the next row here, you are getting a cumulative frequency of 68. It means that in this frequency here, right, this should have been 48. Now, the next cumulative frequency goes up to 93. So this here will definitely be the 45, right? Now, when I'm at 93 now, right, you have 6 more being added. So therefore, this 99 makes sense. And when I jump to the next row, you have 1 more being added, so you get 100. Okay? So this is what your frequency looks like. 20, 48, 45, 6, and 1. Okay? And you're getting 2 marks for this. Now the next part here, part 2, right? They want us to, a student is chosen at random, find the probability that a student estimated a mass greater than 6. Now if you want a mass greater than 6 here, it means that we're talking about these 2 columns here. So the amount of students that did that there, so greater than 6 grams, is simply going to be this student here, these 6 students here, plus this 1. So that's going to give you 7 out of 100. Okay, I hope that making sense. Right? Some people are asking about bearings. I did have bearings questions earlier in class, right? Right. I'm just gonna run through some matrices quickly with you guys. That's a question that you can easily get some marks in the exam for. All right, so first thing that we need to know when it comes to a matrix, CSEC can ask us things like what is meant by the order of a matrix, or they can give you a matrix and ask you for the order of a matrix. Okay, so let's see. So you have a matrix, right? So they can ask you the order of a matrix. So if I have something like this here, let's say 2, 1, 0, 4, 1, 1, and I were to ask you what's the order of a matrix. Now the order of a matrix is written as m by n. That's how it's written. So this first number here is how many rows we have, and this here is how many columns we have, right? Right? So if I look at this matrix here, could you all tell me what is the order of that matrix? Right, so people saying 3 by 2. Yeah, so if we look here, we have 1, we have 2, we have 3 rows here. So it is going to be a 3 by. Then we look at the columns, we have 1, we have 2, so you have 2 columns. So it's a 3 by 2 matrix. Now this comes in your multiple choice as well, guys. So just be aware of it. If I have a matrix that looks like this now, let's say 4, 2, 1. What's the order of this matrix here? Right? I see people saying a 3 by 1. So again, you need to check to see how many rows you have, right? So we have 3 rows here. But when we look at the columns, we only have 1 column. So it's a 3 by 1 matrix. So that's what we call the order of a matrix, right? So order of a matrix. Okay. Now, when you want, let's say, right? Let's say we want to add 2 matrices. Okay. So I have a matrix A here and I have a matrix B here. And the first thing I want to do, I want to work out A plus B. Now, before 2 matrices could be added, what needs to happen is that they must have the same order in order for me to add them. Okay. So if I wanted to work out A plus B, then all I need to do is to write down what A is, which in this case is 2 minus 1, 4, 5. And you're going to add that to B now, which is minus 2, 1, 3, and 4. Now, just remember, when you guys are adding matrices, right? When you're adding matrices, you're going to add corresponding elements. So you have 2 plus minus 2, you're going to get 0. Then we're going to add minus 1 plus 1, and we're going to get 0 again, right? This 4 plus this 3, we're going to get 7. And this 5 plus this 4, we're going to get 9. So that's our answer there when we add matrix A plus matrix B. Okay, so that is part A. For part B now, you want to work out B minus A. Okay, so in this case here, it is going to be minus 2, 1, 3, and 4. And you're going to subtract A, which is going to be 2 minus 1, 4, and 5. So minus 2, right? Looking at the corresponding elements, minus 2 minus 2, you're going to get minus 4. 1 minus minus 1, you're going to get 0. 3 minus 4 will give us minus 1. And then 4 minus 5 will give us minus 1 as well. Okay? So that's what I'm going to get when I work out, or when I add those, when I subtract those two. Right? Some people asking about vectors. Yeah, so I'll be doing some more, right? I can only do up to maybe about 1:30 today, right? But I'll come back online tonight after class. All right. So just look out, right? Right, so that's subtraction. This next one here, if we want to work out something like this, let's say we have A plus 2B. What you're going to do here, so your matrix A is 2 minus 1, 4, 5. And you're going to add that to 2B. So this is a scalar multiplication here. So that's minus 2, 1, 3, 4. So this is 2 minus 1, 4, 5. All right, plus. Now, when you are multiplying, or when you have a scalar multiplication, what you're going to do, you're going to say that number on the outside has to be multiplied by every single thing on the inside here, right? So you're multiplying it by each of those elements here. So 2 by minus 2 will give you minus 4, 2 by 1 will give us 2, 2 by 3 is 6, and 4 by 2 is 8. Okay, so then we're going to add up those two here now, and that'll be our answer. So 2 plus minus 4 is going to give us minus 2. Minus 1 plus 2, you'll get positive 1. 4 plus 6 is 10. And then 8 plus 5, you get 30. So this is simple addition and subtraction, right? Simple addition and subtraction. Now, one of the things we have to be able to do in the exam is to perform what we call a matrix multiplication. Now, students generally have issues with something like this. So I'm going to do the matrix multiplication here for you all. Now, the first thing, when you are multiplying a matrix, a condition must be met in order for us to multiply a matrix. So let's say I have a matrix A and I want to multiply that by a matrix B. What is supposed to happen? So let's say we have a 3 by 2 matrix and you are multiplying that by a 2 by 3 matrix. What needs to happen is that this number here, right, and this number here has to be exactly the same in order for the two matrices to be multiplied. Okay, so if I have a 3 by 2 matrix, let's say I have 1, 1, 2, 1, 4, 2. This here is a 3 by 2 matrix. And a 2 by 3 matrix could be something like this, right? 2 rows, 3 columns. So let's say 1, 2, 3, 4, 1, 0, right? This is a 2 by 3 matrix. These two matrices here can be multiplied because the number of columns in the first matrix is equal to the number of rows in the second matrix. That is a condition that must be met. Now, in terms of the answer is going to be a 3 by 3 matrix. So when I multiply this out here, I should get a 3 by 3 matrix. I'll have 3 numbers here. Right? That is what the matrix is going to look like. So sometimes in the exam, they will ask you, how do you know, right, if the matrix is wrong, right? Right? That's how somebody said B minus A is wrong. Let me go back here. B minus A. Did I write it down wrong? Minus 2, 1, 3, 4. Minus 2 is minus 4. 1. Oh, yeah. Sorry about that. Yeah, I seen it. There should be 2. Right? 1 plus minus 1 is the same 1 plus 1. 4 minus 5. Right? Right, somebody's asking when to use n over 2 and n plus 1 over 2, right? So to tell you the truth, I normally just use n over 2 because you are estimating, right? We are estimating, and our estimates are going to be around the same value anyway, okay? Okay, so let me go back to this matrix multiplication thing. What I want to do, I want to multiply two matrices. So let's get this matrix across here. Right, so we have these two matrices here, and we want to multiply them. Okay, so first of all, we want to work out A multiplied by B. That's what you want. So the matrix A is given by 2 minus 1, 4, 5. And you're multiplying that by minus 2, 1. And this here is 3, 4. Okay. Now, one of the key things you have to remember when you are multiplying matrices, it's always row by column. So the first thing I would normally do, I will say, okay, let's understand the order of the matrix first. So matrix A is a 2 by 2 matrix, and you're multiplying that by matrix B, which is also a 2 by 2. So let's check this number here, and let's check this number here. They are the same, right? These two numbers are the same, so therefore I can multiply them. So my answer is going to be a 2 by 2 matrix. That's what the answer is going to be. Okay, so when I multiply this here, I'm going to get 4 numbers. So I usually use a labeling here in order to label each of the elements. So I'm going to call this E11, E12, this is E21, and this here is E22. So we have 4 numbers that we're going to be looking for here. So how do we work out those 4 numbers? So E11, right, that actually tells me what I need to multiply as well. So in this case here, we're going to take this row and you're going to multiply it by this column here. So that's going to be, now this is how you work this out. So it's 2 by minus 2 plus minus 1 by 3. So that's going to be minus 4 plus minus 3. So we're going to get minus 7. So I have one of the numbers already. Then I need to work out, I can work out E12. So we're going to take the same row from the first matrix, but this time I'm going to switch to this column here. Okay. So when I multiply this, it'll be 2 multiplied by 1 plus minus 1 multiplied by 4. So 2 by 1 will give us 2 plus negative 1 by 4 will give us negative 4. So 2 minus 4 will give us minus 2. So that's our second number here. Right? Then we're going to work out E31. Right? No, sorry. E21. Right? And I'll work out E22. So let's use a different color here now. What I'm going to do, I'm going to switch. So we're going to switch to this row here now. So we're taking this row and we're going to multiply by this column here. So this is going to be 4 multiplied by minus 2 plus 5 multiplied by 3. So 4 by 2 is minus 8 plus 15. Right, that should give us 7. Right, so this will be 7. And then the last one now, we're going to use the same row here, 4, 5. And now we're going to switch to this column here. So that's going to be 4 by 1 plus 5 by 4. So that's going to be 4 plus 20. So that's 24. So right now I have all the elements that are supposed to be my answer. So my answer will be minus 7 minus 2, 7, 24. Right? People ask about crash course for POA. Nope, I don't do POA. Right? Maths, Chem, Phys. Those are the things I deal with, right? Maths, Chem, Phys, add maths. Yeah, you all can check Chris, yeah, adaptation, right? He has a ton of stuff on, right, when it comes to POA. Right, I've seen requests coming in the chat here, right? I'll see what all I can cover, right? All I can cover. All right, so that is A multiplied by B. If you all seen any errors there, let me know, right? Yeah, people asking about inverse as well. Yeah, we'll talk about that in a sec. All right, so that's A multiplied by B, right? Now let's do 1 or 2 questions here as well. One of the things you could be asked in the exam is to find the determinant of a matrix. So the determinant of a matrix could be written like determinant of A. That's one way of writing it. Or they put an A with 2 vertical lines here as well. They both mean the same thing. Now, if I have a matrix M, and the matrix is given by A, B, C, D, and I want to determine the determinant of this matrix, it is simply going to be, there's a formula, A by D minus B by C. Right? So that's our determinant here. So if I want to work out the determinant of A, so let's, right? So the determinant of A here is equal to 2 multiplied by 5, okay, minus 1 by 4. So in this case here, this will be 5 to the 10 minus 4. So that's going to give us 14. All right. So that's our determinant for this particular matrix. So you need to know the formula to find determinant. We have 2 kinds of matrices here that we need to be aware of. We have something called a singular matrix and a non-singular matrix. Now, if a matrix is singular, your determinant of that matrix is going to be equal to 0. Okay? Whenever you see the word singular, it means the determinant is equal to 0. So if I want to work out the determinant of A, this will be 2p multiplied by 5 minus 3 multiplied by 10, right? That's your determinant. So this is going to be 5 to the 10p minus 30. That's your determinant of that matrix here. But since the determinant is going to be 0 because it's a singular matrix, you're going to say, so the determinant of A has to be equal to 0. So therefore, 10p minus 30 is equal to 0. So 10p is equal to 30. So p is equal to 30 over 10, which is equal to 3. So this is a typical question that you can get along these lines here, right? All right. What else could we be asked here? So we have a next kind of question here where they can ask you to find the values of p for which a matrix is singular. So again, let's work out the determinant of A. So that's going to be 2p multiplied by p minus 6 multiplied by 12. So this is going to be 2p squared minus 72. So that's your determinant of E, right? That's your determinant of E. Now remember, for a singular matrix, your determinant is equal to 0. So we will write 2p squared minus 72 is equal to 0. So we're going to solve for p here. 2p squared is equal to 72. So therefore, p squared is 72 all over 2. So p squared is equal to 36. Now, you have to be careful with this here because sometimes students will just put p is equal to the square root of 36 and they will just put 6 as the answer. Now, if you notice here, I said values. Whenever you work out square root in maths, there's usually a positive and a negative answer. So one answer could be positive 6 and the second one could be negative 6. So keep that in mind, right? Keep that in mind. All right. Now, what about inverse of a matrix? Okay. One of the things you can be asked is to find the inverse of a matrix. So inverse, right, of a 2x2 matrix. All right. So first things first. If I have a matrix M, and that is given by A, B, C, and D, your determinant is given by AD minus BC, right? That's your determinant. We also have something called the adjoint of a matrix. All right, now to get the adjoint of a matrix, what you do, you're going to swap the position of A and D. So D will come here and A will come here. So you swap the positions of A and D. In the case of B and C, you're going to put a negative sign in front of it. So you're going to have this. So this is referred to as the adjoint of the matrix. So if I want to write down the inverse of the matrix, so the inverse, which is m to the minus 1, that's how you write it. It is going to be given by 1 over your determinant. So that's 1 over AD minus BC. And you're going to multiply that by the adjoint. So that's DA minus B minus C. So you all need to know this, right? You need to know this. If you want to work out the inverse of a matrix, this is what it's going to be here. Okay? Right? Somebody saying B and C. B and C. Yeah. B and C. Right? You have to put a negative sign in front of B as well as C. I'm just going to do one example here to work out the determinant of a matrix. So let's say I have a matrix M here, and it's given by, let's say, 2 minus 1, and let's say 3, and let's say 4. Right? So let's say I have a matrix M here, and I would have asked you what is the determinant, sorry, what's the inverse of the matrix? If I want to work out the inverse, the first thing I'll do is to work out the determinant. So that's going to be 2 by 4 minus 1 multiplied by 3. So you're working out the determinant of the matrix. So that's 4 2s are 8 minus 1 multiplied by 3 will give us minus 3. So that's the same as saying 8 plus 3. So that's going to give us 11. Now if I want to write down the inverse, you're going to put 1 over 11. And we need to write down the adjoint of the matrix. So you're going to swap the position of the 4 and the 2. And you're going to put a minus sign in front of the negative 1. So this will become positive 1. And this here will become negative 3. Now if CSEC just asks us for a question for the inverse, what you should do is to multiply this out. So the final answer will be 4 over 11, 1 over 11, minus 3 over 11, and then 2 over 11. Okay? So that's going to be our inverse of this matrix here. Right? Right? So like I said, this is called the inverse of a matrix. Okay? Now, when it comes to matrices, there's a special matrix called the identity matrix, which is given by 1, 0, 0, 1. Okay? So this is called the identity matrix. Now, when it comes to identity matrices, there are some rules regarding the identity matrix. If I were to take a matrix A and I were to multiply it by its inverse, then what I'm going to get for my answer, it is going to be the identity matrix. If I were to take any matrix and I were to multiply it by the identity matrix, I'm going to get back that same matrix. If I were to take the identity and multiply by any matrix, I'm going to get back that same matrix. Now, these are just some rules when it comes to matrix multiplication involving the identity matrix. Okay? Now, one thing that I feel that we're going to get tomorrow, right? I feel like we're going to get one of these tomorrow. I suspect we're going to get a simultaneous equation, right? I really feel so. So I'm going to do one here, right? I'm going to do one for you guys here. So we have a pair of simultaneous equations that we want to solve using what we call the matrix method, right? So we have a pair of simultaneous equation and we want to solve it using matrix method. So first of all, when you have your simultaneous equation, you need to write this equation in a matrix format first of all. So to do that, we're going to look at the coefficients of all your x's and your y's. So in this case here, you have 2, we have 5, we have 7, and we have minus 3. Okay? So we're going to extract a 2 by 2 matrix from the coefficients of the simultaneous equation. What is going to be in the next bracket here is going to be xy, and that is going to be equal to 11 and 80. Okay? So that's step 1. You have to write your simultaneous equation in terms of a matrix. That's step 1. Okay? Now what do we do next? So there is a matrix of concern to us here, and that is this matrix here. So we have to do some things with that matrix before we can do anything. So let's call that matrix M, and that'll be 2, 5, 7, minus 3. Okay? So that's our 2 by 2 matrix that I'm working with here. So what do I do? The first thing I really need to do is to find the inverse of this matrix. So step 1, let's find the determinant. So the determinant will be 2 by minus 3 minus 5 multiplied by 7. So this is going to be minus 6 minus 35. And this is going to be minus 41. Okay? So just double check my determinant there. right? So that's my determinant. So the inverse of this matrix, which is what we really need, is going to be negative 1 over 41. And the adjoint matrix will be minus 3, 2, minus 5, and minus 7. Okay? Now, when you are given a question involving simultaneous equations, what I normally tell students to do is, you see, when you work out the inverse, don't multiply it out. Leave it as is here, right? It is much easier to work with it like this when you work in this problem. So the first thing we're going to do now, right? The first thing I'm going to do here, I'm going to take that inverse, that's this, and we're going to multiply the left and the right-hand side of this equation by that matrix. So we're going to say minus 1 over 41. The inverse would have been minus 3 minus 5 minus 7 and 2. Okay. And here will be 2, 5, 7 minus 3. This is xy. And on the right-hand side, we're doing the same thing. So it's going to be minus 41. And this is going to be minus 3 minus 5. Right? And this is 11 by 18. Okay? So some of y'all might be watching this and thinking it's getting very complicated. But the only thing I've actually done here, guys, I've actually just, the difference between this line and this line is that I've added this here. I'm multiplying both sides of the equation by the inverse. That's what I'm doing, right? So I'm multiplying both sides of the equation, right, by the inverse, right? Right? I know see in the chat there, Cohen sent you guys. Yeah, so sometimes we try not to clash, guys, when we're doing our lives. All right. So I mean, today is the last day before class, and sometimes we do we all do some lives, right? That includes Cohen, that includes Chris as well, sometimes do a live, right? So other people do lives as well, right? So make use of it, right? Make use of it, guys, right? Cohen has done a lot as well, right? So his live has been recorded, my live has been recorded. There's a ton of resources you guys have access to, right? Back in the day when we would have done maths, right? Back in the day when we would have done maths, we never had these resources. We just had a teacher and that's it, all right? So welcome for some of you all who came across, all right? Yeah, so we're doing a lot of stuff here, guys, right? And chances are I'm gonna go later tonight. I have a class this evening, so after class I'll come back live again. Okay, so we're trying to solve this equation simultaneously here. So the first thing I did, I worked out the inverse, and then what I'm doing here now, I'm going to, on the left-hand side here, remember I just told you all that if I take a matrix and I multiply by its inverse, right, I'll get the identity matrix, okay? The same applies if I take the inverse and multiply by the matrix, I will still get the identity. So on the left-hand side here, what really happening here is that you're going to end up with just x and y. Okay, so the whole left-hand side here, it just becomes x and y. That's it. Okay, now this minus 1 over 41, let's leave that right here. And then what I'm going to do now, I'm going to do a row by column multiplication. So in this case here, let's take this row here and let's multiply by this column here. So I'll do this on the side here. So that's minus 3 multiplied by 11, right? Plus minus 5 multiplied by 18. Now, I hope this works out. I find the numbers looking kind of big. So that's minus 33 plus minus 5 by 18, close brackets. Right, I'm getting minus 123. Right, so this here will be minus 1, 2, 3. Then we need to do this row now, multiply by this column here. So this is going to be minus 7 multiplied by 11 plus 2 by 18. So in this case here, we have minus 77 plus 36. We're going to get minus 41. Right? So you're going to get minus 41 here. So the next step now is to simply multiply on the right-hand side. So we're going to get xy is equal to So minus 1 over 41 multiplied by minus 123. So divide by 41. You're going to get positive 3 here. And then for this one here, we are going to get 1. Okay? So therefore, x is equal to 3. And y here is equal to 1. All right? That's it. X is equal to 3 and y is equal to 1. Okay? So I hope that that makes sense. All right, so some of you all who came across, we went through we did a bearing question, we did some transformations, things that you need to pay attention to. All right, some students wanted to know how to do a simultaneous equation. Like I said, right, I honestly feel tomorrow we may get one of this. So make sure you know how to solve a pair of simultaneous equations. That's important, right? All right, let's see if I can get one more question inside here. Oh, by the way, I did a speed time graph as well. I did a speed time graph as well. Right. I know some people are asking about a function question, right? Let's see what you need to know for functions. So functions, those questions can be relatively straightforward if you know what you're doing. So if I have a function f of x is equal to, let's say, 2x plus 1, and I have g of x is equal to, let's say, 2x squared, right? I have two functions here. If I were to ask you something very basic, if I were to ask you f of 2, then all I need to do is to substitute 2 into that function. So this here is going to be 4 plus 1. That's going to give you 5. So that's a very simple question that you could be given. CSEC can also ask you to work out what we call the inverse of the function. They want you to find f inverse of x. So if I have a function f of x is equal to 2x plus 1. So f of x is equal to 2x plus 1. And I want to find the inverse. The first thing we do, we let y equal to 2x plus 1. So that's step 1 in your problem solving here. The second part here, or the second step, is to interchange x and y. So this becomes x is equal to 2y plus 1. So the third step is to make y the subject of the formula. So what I normally do, I will write 2y plus 1 is equal to x. And therefore 2y is equal to x minus 1. And therefore y is equal to x minus 1 all over 2. So therefore, I normally tell students, even though you work this out, just put a statement, at the end to tell them what the inverse is. So the inverse is going to be x minus 1 all over 2. Okay? So that's your inverse of the function. That's a second thing they can ask you in the exam. The third thing they can ask you is in relation to a composite function. So what they could do, they can tell you here what? Let's find g f of x. That is a composite function here. How do we deal with a composite function? Well, all you need to do is read this from the right hand side. So we're going to say f, you're going to plug that into g. That's what you're going to do. So when you're doing a composite function, you're going to start from the right hand side and you're going to plug that into the function. So basically, we're taking all of this is f of x, and you're going to plug that into this here, right? But you're plugging that as a value for x in this case here. So when I work this out, I'm going to get, so this is going to be equal to, so 2 multiplied by 2x plus 1 squared. Now, sometimes CSEC is going to tell you here what? They want you to simplify this. So to simplify this, let's leave the 2 right here. But this is really 2x plus 1 multiplied by 2x plus 1. That's basically what we're working on. So in this case here, we can leave the 2 as is. But when you're multiplying those two brackets here, you have to remember, multiply this in a systematic way. So you're going to say 2x by 2x. You're going to say 2x by 1. you're going to say 1 by 2x, and we're going to say 1 by 1. So make sure you understand exactly what you are multiplying out. Okay, so in this case here, we're going to get, oh, sorry. Yeah, so 2x by 2x will give us 4x squared. Then we have our next 2x here. Then we have our next 2x. And then we have 1. So this is going to be 2 by 4x squared plus 4x plus 1. And the final answer is going to be 8x squared plus 8x plus 2. Okay, so this represents my composite function here, right? This represents my composite function here. Okay. Right. Yeah, so I've seen a ton of requests for certain topics, right? I'm seeing a lot of requests for certain topics. So like I said, I would have started probably around 11 o'clock. I will be coming back after class. I have a class later today, so I'll come back online after class. So whatever topics you all want me to go through, right? I'll try my best to see what I can, right? So I am seeing all the requests, but like I said, this session was supposed to end at 1:30. I'll give you a few minutes again, right? Because I have another class that I actually have to go teach in a little bit, right? It'll probably be around maybe 6:30-ish around there, right? So look out for around there, right? Right, so let me see. Right, we're still on functions here, right? Let me show you one of the most difficult function question that it can give us. Or actually, let's say we have something like this. Let's say we had f of x is equal to 2x minus 1. And let's say we had g of x is equal to, let's say, 4x plus 2. All right. And I would have asked you to find, let's say, fg of 2. All right. Let's say I wanted to work out that. Now, some students, what they will do, they might go and find fg of x first and then plug 2 into it. But there's a shorter way to work this problem, right? No need to make life more difficult. Since you read composite functions from right to left, what I would do in a question like this, I will work out g of 2 first. So g of 2 will be 4 by 2 plus 2. So that's 4 2s are 8 plus 2. And that's going to give us 10. Now that answer that I get now, I'm going to plug that into the function f. So I need to work out f of 10. So this will be 2 by 10 minus 1. So this is going to be 20 minus 1. So that's going to give us 19. So therefore, fg of 2 is going to be equal to 19. Okay, so that is what we refer to as a composite function. That's something you could get in the exam. Also, there is a function. Let's say we have f of x is equal to 2x plus 1 all over x minus 2. And let's say CXC would have asked you here what? Find f inverse of x, right? That's one thing they can ask you. They can also ask you to state the value of x for which, right, f of x is equal to 0. Okay? Sorry, say now. F of x is undefined. Right? These are things they can ask you based on this particular function here. So find the inverse. That'll be a little longer. But they can also ask you to state the value of x for which the function is undefined. Now, one of the things you all need to remember is that if I take 0 and I divide it by any number, the answer is going to give me 0. However, if I take any number and I divide it by 0, you're going to end up with an error on your calculator. Anything divided by 0 is considered undefined. So if you want to find the value of x for which the function is undefined, you see this piece at the bottom here? The function is undefined when that is equal to 0. So when they ask you to state, all you need to do is to put the denominator equal to 0, and therefore x has to be equal to 2. So this here is your answer for this part here. State the value of x for which the function is undefined. Okay. So that's usually easy market, right? The next thing here now, let's see f of x is equal to 2x plus 1 all over x minus 2. And you want to find the inverse of the function. This is the most difficult inverse CSEC can give us. So the first thing we're going to do, we're going to let y equal to 2x plus 1 all over x minus 2. Then what we're going to do, so that's step 1. The second step is the interchange. So you're going to say x is equal to 2y plus 1 all over y minus 2. So what we're going to do, we're going to first write this as x over 1, and then we're going to cross multiply. Okay. Now, when you work a problem like this, sometimes students get a slightly different answer, and that's okay. So this will be x by y minus 2 is equal to 2y plus 1. Okay. So remember, the first step was to let y equal to whatever the function is. The second thing was to interchange x and y, which is what I did. And then the last step is to make y the subject of the formula. So I cross multiply. So this will be xy minus 2x is equal to 2y plus 1. So let's carry all the y's on one side. So xy minus 2y is equal to 1 plus 2x. Okay. Now the next thing that we're going to do here, we're going to factorize on the left hand side. So we have y, and this will be x minus 2 is equal to 1 plus 2x. So therefore y is equal to 1 plus 2x all over x minus 2. So therefore your inverse of this function here is going to be equal to 1 plus 2x all over x minus 2. So like I said, this is the most difficult, right? This is the most difficult type of matrix question that can come in the exam, right? Right, I've seen people talking about the paper 2. So please ignore all of those comments about leaked papers. As far as I'm aware, right, and the paper has not been leaked at all, right? As far as I'm aware, the paper has not been leaked. Okay, and let's hope it stays that way. Let's hope it stays that way. For your sake, really, for your sake. All right. Right. Some people ask, so when I'm ending, yeah, so I'm gonna end in a little bit, all right, because I started a little while now. All right. Let's see if I can stick in maybe one question, maybe. Yeah, I might be able to do one more question with you guys, right? Right. Right. I know some people are asking in the exam which question you should start with first. So you know you have 10 questions in the exam. My suggestion to you guys is to aim for the questions that you are comfortable with first. right? Don't do questions that are difficult first. So question 1, definitely start with question 1 first. A lot of people have trouble with algebra, so I would avoid that unless you're strong in algebra to do that, right? Functions is an easy question. The pattern question, question 7, is an easy question as well. Statistics can also be straightforward. All right, so here's what's happening here. We have these points A, B, C, D on the circumference of a circle with center O, and we want to state with a reason why angle ABC is 90 degrees. So where is ABC? So this is A here, this is B, and this is C here. Now, if you have to explain or state with a reason, the first thing we have to say is that this line here, AC, is a diameter. You know it's a diameter because it's passing through the center of the circle. So if we try to create an angle using a diameter, you're going to get a 90-degree angle here, right? Or you can say the angle in a semicircle is 90 degrees. That's it. Okay, that's all we need to say. The next thing we want to calculate angle BAC. Okay, so to calculate angle BAC, that's this angle here. So you have a triangle here. Remember, this is 90 degrees. So all I need to do, I will say that 2P, all right, plus 3P is equal, well, plus 90, sorry, is equal to 180. So if I add up all the angles in that triangle ABC, it should add up to 180. So this is going to be 5P plus 90 is equal to 180. So therefore 5P is equal to 180 minus 90. So therefore 5P is equal to 90. So P is equal to 90 over 5. So therefore P is equal to 1. That's 18 degrees here, right? So that's our angle BAC, BAC, right? Oh, sorry, that's P, right? So BAC is equal to 2P. So that's going to be 2 by 18. So you're going to get 36. All right. So that's a good thing to always do. When you work out or you calculate something, just make sure that you double check your answer. So you see, I worked out P here and I thought that's the answer. But the question wanted BAC. So you have to multiply by 2. Okay, to get angle BAC. The next angle they want me to work out here is angle Q. So angle Q is this angle here. So the first thing you need to recognize here is this. This line here is a chord. And if I use the ends of the chord, so remember this angle here is 36, right? This is 36. Yeah. So this angle here is 36 degrees here. If I use the ends of the chord BC, I can create an angle of 36 degrees here. If I take the same points B and C, I can create an angle here which is the same as well. Okay, so angle Q is going to be the same as 36 degrees. So the angles in the same segment are equal. That's one of the rules we're using here. The angles in the same segment are equal, right? Next part here. Want to calculate the value of R. So in this case here, you will notice that this line here is parallel to this line. So if this angle here is 36 degrees, it means that angle R here is going to be the same thing here as well. So R is also going to be equal to 36 degrees. And we're using the fact that this angle here and this angle here, they are alternate angles, right? So the fact that this line here is parallel to this line, it means that this angle here, this 36, and this R here, they are considered alternate angles. Okay? All right. So, all right. So you guys have been getting a ton of help from us guys. All right. So I'm going to have to sign off for now, right? I'm going to have to sign off for now. But I will come back after my class this evening. I have an AdMaths class this evening. All right. So once I'm finished with that, I'm going to come back live. So just keep an eye out, right? Keep an eye out and I'll come back live and I'll see how much time I can give you guys again. All right. Everybody's here to help you, right? To see how best you can manage with this exam tomorrow. hopefully we get a nice exam tomorrow, right? So I'm going to pause for now. Like I said, I'm going to come back a little later, probably around 6:30, right?